Alright, so here's example 7 for probability. For any natural number m, define a natural number n to be a partner of m if and only if there exists a non-negative integer a such that the following equation holds. So n plus a is equal to m squared. So let me just demonstrate an example. For example, 7 is a part of 3 because we can set a equals to 2 to get 7 plus 2 based on our equation is equal to 3 squared based on our value of m, which is all in all equal to 9. So we can indeed show that 7 is a partner of 3. So that's the definition of this partner relationship, I should say. Alright, so let's just answer these following questions. So for part A, for a random integer x taken from the set 1 to 2 and all the way up to 64, find the probability that 2021 is a partner of x minus 1. Well, finding and testing the values of a that makes 21 a partner of x minus 1 would kind of be tricky, so let's just try to change this into an inequality. So notice that we can change this into n is less than or equal to m squared, where equality holds when a is equal to 0. Notice that this makes sense because a could be 0 positive, which makes n could be less than or equal to m squared. So we have turned this equation into this inequality, which means that we can solve part A quite easily. So let's see, 2021 is a partner of x minus 1. So substituting our values of m and n to our just found inequality, we have 2021 is less than or equal to x minus 1 squared, and taking the square root of both sides, and note that 2021 is something like 44.9 something, which is relatively close to 45. So you can round this to 45 to the nearest integer. So this inequality turns into x minus 1 is greater than or equal to 45, or in other words, x must be greater than or equal to 46. Now checking these values to our set, we see that there are 19 possible values for our value x in this case. So therefore, our probability for taking a random x such that 2021 is a partner of x minus 1 will be 19 over 64, where 64 is the number of elements in our set in A. So this is our answer. For part B, for integer p taken randomly from the set 1, 2, 3, 4, 5, and an integer q taken randomly from the set 1 to all the way up to 25, find the probability that q is a partner of p. Well, the way I would solve this problem is to divide cases. So we can assign a random, we can assign p to be a certain number in this set 1 to 5. So yeah, let's just work these cases out. So let's assume that p is equal to 1. Therefore, with our equation, we have q is less than or equal to 1. And we can see that there's only one solution, or one choice in this case. Similarly, if p is equal to 2, this makes q to be less than or equal to 4. And again, we can see that there are 4 solutions. And if you notice the pattern right here, the number of solutions here is actually p squared. So we can just continue this on. So let me just write the values right here. So if p equals 3, 4, and 5, the number of solutions for q will be 9, 16, and 25 respectively. Now these are all of the possible cases for our criteria. So if we sum them up, we have 55 total solutions, or I would say ways or combinations, if you would call that. So our probability will be 55 over the total number of combinations right here. So notice by the multiplicative rule in counting, we can just multiply the number of combinations or ways for the values of P and Q. Notice that the number of elements for the choice of P is 5, and then the number of elements in the set for the choice of Q is 25. You can check that on your own. You can simplify this to get 11 over 25, and this is our answer. Now I will leave question C as a bonus question, which is an exploration question. When is a natural number x a partner of itself? Or in other words, when is x a partner of x itself, right? Well, the clue here is to use our following equation right here and see what values you can get from that. And that also ends this video and this example. Thank you.